Hello, students. How are you? I hope you are fine, good, and well. Let's begin with our lecture. We will now discuss about surds in number system. So, what are surds? We will know. Then we will know about laws of surds, operation, comparison of surds, and rationalization of surds. Let's jump into our topic, surds. So, surds are the values in square root that cannot further simplified into whole numbers or integers. Okay, so surds are values in square root. Okay, so surds are not just limited to square roots. It can be the cube root or the fourth root or the fifth root. Okay, so clear. Take an example of cube root of 4. Cube root of 4. We read this as cube root of 4, which is a surd. And we say the quantity under this root named as radicand, which is, we can easily say uh, from the definition of rational number, that this number, this 4 is a rational number, because we can write it as in the form of p upon q, where q is not equal to 0. Clear? Okay. Now let's see similar examples. Cube root of 5 is also a surd. Fourth root of 12 is also a surd. Fifth root of 7 and the square root of 12. These are all examples of surds. I hope this is clear. Let's move on. 2 root 3 is also a surd, and this representation can also mean like this, that 2 is multiplied by root 3. Okay, clear? So it is a example. It is an example of a surd. Clear? In a similar manner, we can add a rational number and to a surd, just represent it like this, and it is also a surd. Surd adding some rational number will give me a surd. I hope this is clear. Now let's see third type, that square root of 7 minus 4 square root of 3. So this is also a surd, because if you see that 4 minus root 3 is equals to 2 minus root 3 whole square. Okay, and 2 minus, let's simplify that a square minus b square is a square minus 2ab plus b square, which is root 3 whole square. Now let me simplify more. It is 4 minus 4 root 3 plus 3, which is equals to 7 minus 4 root 3. So we saw that 7 minus 4 square root of 3 is a perfect square of this. Clear? Let's move on. The similar examples are here. So these all are some square roots. For example, this one is of 2 plus root 3 square, which is a square, which is 4 plus 2ab, which is 4 root 3 plus b square, which is 3, which is equals to 7 plus 4 root 3. Similarly, you can find these also. I hope you will find them without any difficulty. Okay, and we know root 3 is a surd. If we apply another root, a cube root or fourth root, this will come out also be a surd. So this is also a surd, and we know. Let me give you that if something like is given root of a, which is we uh, say sometimes like square root of a, which means that a raised to the power 1 by 2. Similarly, it is cube root of a, where we can in other form we can rewrite it as like 1 by 3, that is a raised to the power 1 by 3. Similarly, if 4, then a raised to the power 4. In a similar manner, we can write any given root as in the form of this fraction power. Clear? So as it is given, we change root 3 to 3 raised to the power 2, and then we know that the power is 1 by 3 also. So 1 by 3, and we know that it the both the powers will multiply with each other. This will give me 1 by 6. Okay, or I can rewrite it as like this. Okay, or the sixth root of 3. Similar examples are here. These all are examples of surds. I hope from the examples uh, you can easily explicitly say that which are surds and which are not. Okay, now let's jump to the laws of surds. So what are the different laws of surds? Let's see. We can easily see that if the nth root of a raised to the power n is given, then we can rewrite it in the form like nth root of a power n. Clear? Which is further equals to a. Let me show you what it, let me draw for you that I have given like this. Okay, I know that I can rewrite it like in this form, and I know that the I can product the powers, I can multiply them, so it will become 9 n times 1 divided by n, which is further equals to n by n, and I know the same number is divisible by the same number. I will get the answer 1, which is a. I hope this is clear. Let's see from an example. The cube root of 8. I know 8 is, I can rewrite 8 is as like 2 times 2 times 2, which is 2 raised to the power 3. Now we are talking about cube root of 8, which is I can further rewrite as 1 by 3, and 8 is equals to 2 raised to the power 3, 1 by 3, and I know from the above law that it is equals to 2. Clear? In a similar manner here we can solve. Let's jump to the next law. So the next law says if nth root of a multiply with nth root of b, then we can say that the nth root of a into b. Clear? Here the main important point is that this, the nth root is the same. Okay, the order should be same. Order, what do we mean by order here is this, the taking root value, or the in term of what root we are taking, we considering it as order. So if this and this values are same, then we can rewrite it as like this. Okay, for example, Let's see. Cube root of 2, cube root of 6, we can rewrite it as from the above law, because the order is same, this value is same, and we can multiply the inner values. The inner values get multiplied, and thus root of same order applied. So cube root of 2 times 6, which is cube root of 12. Clear? But here, if you see, the order are not equal. The order are not equal. So the orders are not equal. So it is not equal to some root, some value. Okay. So it is not equal to some value root times 6. Okay. So it is not equal. So the order should be same. It is very important. Very important point. Okay. Okay. Now let's see other laws. Here, if nth root of A divided by nth root of B, here also give thought that the order is same. So order must be same values. Then also we can say that it is equals to nth root of A by B. Okay, A by B. If you take an example, let's say root of 4 divided by root of 16. We can explicitly see what will happen. We know root of 4 is 2. Yes, it is. And root of 16 is 4, which is 1 by 2. I can easily say. Now let's do like this. So it is further equals to, because the order is same here and here, order is same. Why order is same? The root 2 of 4 is equals to root 2. Okay, root 4. We in the case of this 2, we don't write. Usually we just write the symbol only, and the meaning is by itself that 2 is presented here. Okay, so these both are equal. So root 4 by 16 from this law, then equal to, we know it will cancel out, 1 by 4, 1 by 4, and I know that 1 by 4 is, because 1 by 2 times 1 by 2, which is further equal to 1 by 2 whole square root, which is equals to 1 by 2. So both these values are equal. So we verified. So verification is done. That this is holds. Okay, clear? Now let's see the fourth property, what it says. The fourth property says that if a number, this is a number which is product of and m, and root of nm root of a is equals to, I can rewrite it as like this, mth root of nth root of a, mth root of nth root of a. Okay, if you see from an example that first root 2, I can rewrite root 2 as 2 raised to the power 1 by 2. Yes, I can. Now again, this root can be further rewritten as 1 by 2 and multiply with it. Again, this root I can erase and write it in the power form. So after multiplying, I will get 1 by 8, and this will change into eighth root of 8. Okay, eighth root of, sorry, this will be 2. Clear? So eighth root of 2. I hope this is clear. Okay, so now so the answer for this is, or the simplified form for this is, the eighth root of 2. Okay, now let's move to next. The fifth property. Fifth property says, if nth root of a, the nth root of a, nth root of a can be written as like this: n multiply p, this is n multiply p, or I can say that np, npth root of ap. What we say that npth root of ap. Clear? So here the clear. I hope this is clear. Now in other form, or generally, I can say that nth root of am, nth root of am is equal to npth root of mp. Npth root of mp. Let's take an example to understand it better. So here it is given that cube root, or the third root, cube, we say cube here, cube root of 6 raised to the power 2, which I can rewrite it as like this, that if I am multiplying with 2, then I have to multiply with 2 inside also. So it is quite simple. If we are given like this, nth root of am, and someone is multiplying with p here, then the person must also multiply with the same number inside the power of a, like this, m multiply with p. Clear? Okay, so this will turn out to be the sixth power of, sorry, the sixth root of 6 raised to the power 4. Clear? And similarly here one can easily understand. Okay, so here cube root of 6, so making the order 15, how we are going to make 15 here? So just multiplying with 5 here, so I will also multiply 5 here. So 1 is already there, I can multiply 5, so it is given like this. So this will turn out to be 15, and this will turn out to be 5. So the 15th root of 6 raised to the 5. So I change this the order of 3 to order of 15. So still they are equal to each other. Okay, now let's move. Now we'll see the operations on surds. So we will see the different operation we can operate on surds. So in the first operation comes in mind is addition and subtraction. So can we do addition and subtraction of surds? So let's find out. If there's only one condition, if the condition satisfy, then can only I be able to add two surds, or even subtract two surds. So what is the condition? The main condition for to add or subtract any surds is the order and the radicand. The order and the radicand are the same. For example, cube root of 3 minus cube root of 3. So here this order is same and this radicand is also same. So I can easily say, because the both values are equal, same, so the answer will be 0. Let's take another example. So if cube root of 8 is the cube root of 8 minus 2 times of cube root of what? 8. So here the order is same, the radicand is also same. So here if we see the cube root of 8 getting subtracted from 2 times of cube root of 8. Here only 3 cube root of 8 is given, which is equals to 1 multiply with cube root of 8. Okay, 1 multiply with cube root of 8. So I know, so easily I can see that 1 multiply with cube root of 8, 1 multiply with cube root of 8. So I rewrite this. So 1 multiply with cube root of 8 minus 2 multiply with cube root of 8. So 1 multiply with cube root of 8 minus 2 multiply with cube root of 8, I will left with, so bigger value is this. So the sign is minus, so the minus will be here, and the 1 multiply here, the cube root of 8 is 1 times, here the cube root of 8 is 2 times. So subtracting 2 from 1, we will get 1, and the remaining thing is cube root of 8. Okay, so our final answer will be minus of cube root of 8. Okay, I hope this cleared your operation of surds with addition and subtraction. Let's move. So here's our example here. So the order is same here. So the order is same. We know the order is same. Order is same. But if we see for the radicands are not same. So we try to make the radicands same, so that we will apply our laws or rules to simplify our questions. So let's make it. So root 6 is, yes, we know 216 is 6 into 6 into 6, which is 6 cube. Okay, so 6 cube is 216. So we rewrite it as square root of 6 cube. Now what about the 96? So 96 is just nothing, is 16 times 96 is 16 times 6. Okay, 16 times 6 is 96. So we rewrite it as like this, and we know 16 is 4 times 4 into 6. So 4 times 4 into 6. Okay, now what? Now I know from the law that I can rewrite it as 4 times 6 as 4 4 raised to the power 2 multiplied by 6 root of this. And I know from a law that root of A, root of B is equals to root of AB. So this is AB, I can separate them. So 4 square root multiply with root of 6, and I know that the root of 4 square is equals to 4 square raised to the power 1 by 2, which is further can easily evaluated like from a law that it is equals to 4. If you remember the this nth a n which is equals to a. Okay, now we know it is 4 times root 6, which is further or root 6. Now this 6 cube plus 4 root 6. Okay, so I've made the radians similar for this, but here the radicand is 6 cube. So I somehow have to change it. Okay, so now what I'll do in this case? So I'll do just a simple thing. So what I'll do, or you can see that I can add them because both have same order and the same radicand. So it will be, here it is 1 times root 6, here 4 times root 6, it will be 5 times root 6 minus root of 6 cube. Okay, clear? I hope this is clear. You can leave it here, or you can further simplify if you want a more accuracy or this cube to be removed. Okay, so let's see how the steps are. Now let's move to the next questions. Okay, so I hope the previous was clear enough. Okay, now let's move to next. So for for this 5 times of cube root of 250, I can rewrite it as like we know 250 is equals to 125 times 2, and 125 is 5 times 5 times 5, 5 times 5 times 5 times 2. So 5 times cube root of 5 times 5 times 5 times 2, which I can also rewrite it as like 5 cube. Using laws, it is, I can again break into two parts, which is like this, and from a law it is equals to 5, and it is remain same, and this is 25 cube root of 2. So this is 25 cube root of 2. Okay, now what about this? So it is also same, like 16 can be rewritten as 2 times 2 times 2 times 2, which is 2 cube into 2, and I know that I can rewrite it as like 7 cube root of 16, which is further equals to 7 cube root of 2 cube times 2, which is from law I can separate them. 2 cube times cube root of 2, from a law it is equals to 2 into cube root of 2. So you see this property the nth root of a n is equals to a, it is very handful in our questions. Okay, so do remember it or do memorize it. Okay, so from this it is 14 times cube root of 2. In a similar way, we can change this. So what it's 54 is 27 times 2, and 27 is 3 cube times 2, and then this can be further changed into, here it is this, and 14 times cube root of 3 cube times cube root of 2, which is from this property, it is from this property. Okay, so let me I think the whole thing is erased, so let me do it again for you. If I but I'll be quick for this time. So this is 5 cube root of 250 is equals to 5 cube root of 125 times 2. 125 is 5 cube, and using the properties I can write it as like 25 cube root of 2. Okay, now 7 cube root of 16 is equals to 7 cube root of 2 cube times 2, which further equals to 14 cube root of 2. Okay, now 14 cube root of 54 is equals to 14 cube root of 27 times 2, and 27 is 3 cube, and which further equals to 14 times 3 cube root of 2, and 14 times 3 is equals to 42. Okay, now we just have to do the given operations. So here let's give 25 cube root of 2 plus 14 cube root of 2 minus 42 cube root of 2, which is equals to, here 25 plus 14 is 39 cube root of 2 minus 42 cube root of 2. Now these things are both the same, and we know we now just have to do 39 minus 42, which is minus 3. So we are left with minus 3 cube root of 2. So the final answer is minus 3 cube root of 2. Okay, let's move to another question. So this one is also the same. So the answer is minus 3 cube root of 2. Okay. This is your let me do it for you. You otherwise you will see this is difficult for you. And okay, so 4 square root of 3. Okay, no problem. Now 3 square root of 48. We know 48 can be rewritten as 16 times 3. 16 times 3, and no, 16 can be rewritten as 4 square times 3. So applying roots, I can break it down like 4 square times square root of 3, and using the property of n, root of an is a. We know root of 4 is equals to square root of 4 is the same. Okay, which is from this property, I can write like 4 root 3. So this is 4 root 3. This is also 4 root 3. Now this. Here we have to somehow make root 3. But here it is given 1 by root 3. So we just do nothing. Just multiply 3 up and down in the numerator and the denominator. Now it is 3. So 1 by 5 by 2, root 1 by 3 is equals to 5 by 2. Root 1 times 3, 3 times 3, it is equals to, so what it equals to, it in numerator it is 3, in the denominator it is 3 square. So if you remember that n of this and the n of b is equals to whole n of a by b. So I can again rewrite it in this form, root of 3 square, and from this property the denominator becomes 3 only. So 3. Now it is multiplication here. So 5 root 3 is 6. So now minus 5 root 3 over 6. Now just do the operations. So adding this will get me 2 into 4 plus root 3, 2 into 4 into root 3, sorry, into 4, which is 8 root 3, and minus 5 by 6 root 3 minus 5 by 6 root 3. So this is both are the same, so we write as root 3 here. 8 minus 5 by 6. Now we have just solved 8 minus 5 by 6. It is quite easy. It is just fractions. So we do take LCM. Here is 6. Let me use chalkboard. 8 minus 5 by 6. So taking LCM is 6. It is 48. So it is 48. Now minus by 5. So 48 minus 5 gives me 43. 43 by 6. Okay. So 43 by 6. So the final answer is 43 by 6 root 3. Okay. I hope this is clear. Let's move to next. Okay. I hope something is get okay. So I have okay. So here I skip this 3. So sorry for that. So just for this, what I have solved for this. So just please do a correction in the question I have solved for this question. Okay. So the question which I gave you the answer, the question which the answer is 43 by 6 root 3 is the answer of question. Let me rewrite the question. 4 root 3. Okay, 4 root 3 plus root 48 plus root 48 minus 5 by 2 minus 5 by 2 root of 1 by 3. Okay, I have solved for this and this answers for this. Okay, I somehow skip this 3. So you do it, this question you please do it as your homework. Okay, and what I have solved is for this question. Okay, so the steps are similar, just similar. So okay, clear. I hope this is clear to you. Okay, Let's move. Now, operation like multiplication and division of surds. So, multiplication and division only happens when the order is same. So, here order is same. So, I can multiply 4 and 22 easily with the order being the same. So, 4 times 22, I can write 4 is 2 square and 22 as 2 times 11, and I know 4 times 22 I can rewrite as 2 square times 2, 2 raised to the power 1. Here is 1, here is also 1, is 11, and 2 square into 2 1, the total number of 2 are 3. So 2 cube into 11. So 2 cube into 11 is equals to what? So from using properties I can break it down. So which is, if you see the cube root of 2 cube multiply with cube root of 11, so it is from the property it is equals to 2, and other things are the same. So here is the answer. Let's see for the next one. Here the order is not, so here the order is not equal. So in order to multiply them, we make order same. So the order is 3 here, the order is 4. So how we are going to make same order? Just it is quite a simple task. It is quite simple task. So the question is given this. Okay, the question is given like this. So do nothing, just follow this step. So take out uh, these numbers. The numbers are 3 and 4, and take LCM of those numbers, which is 12. Okay, now use the property or the law. Use the law. What law I am talking about? So the law is that if n a is given, then I can rewrite as n into m a m. Okay, so here I can um, rewrite cube root of 2 as 3 into 12. Okay, sorry, 3 into 4 with and 2 4 and 4 root of 3, which is equals to uh, 4 into 3 3 3. Okay, I hope this is clear. Now what this do? So now our order is same, which is 12. So the LCM. Okay, so we somehow make our order equal to the LCM we have taken or we have gotten. Okay, so this. Now I know. So now this is quite simple. Now just multiply them. It is both are equal. Now the orders are same. So I can easily multiply with each other. So 2 4 3 3. So you can evaluate it further to get your final answer. Okay, I hope this is clear. So the final answer is this. Okay, so 2 raised to the power 4, 3 raised to the power q. So 2 raised to the power 4, 3 raised to the power q. I hope this is clear. Let's move further. Now here is a question based on just previous multiplication. Okay, so how we are going to do? Just simple steps. First check for check for same orders, same orders, same order. So here orders are not same. Okay, so then do if order not same. Second, if order are not same. If orders are not same, if orders are not same, then what we will do? We will do the LCM, जो in just like in previous I have done. So then make order equal to LCM. Okay, LCM. Okay, so now here orders are not same, so the take values of this is 2, the value is 3. Now taking LCM, what I will get? 6. Now I have to make order of 6. So how I am going to make? Let's see. So 8A5P, which is further equals to, here it is 2 written. We don't usually write, we just use the symbol, but here it is 2. So what I will multiply so that I can get 6? So just I will multiply with 3. So 3. So now I have to multiply the power of this term with 3 also. So A 5, B 3. Okay. In the similar manner I will do for this. Okay. So to make order 6, I multiply with 2. So 4A square B square 2. Okay, I hope this is clear. Now what I'll do, I will do just simplifications. It is 6. I'll give powers 8, 3, A 5 times 3, which is 15. A 5 times 3, which is 15, and B 3, which is further, and this one is equals to 6 here. 4 power 2, A 2 times 2, which is equals to 4, B square times 2, which is also equals to 4. Now I can easily multiply them. So now multiplying them, I'll get 6 here, A 3, A 15, B 3. Multiply, the multiplication is also here, but it is hidden. So B 4. So multiplying. So I'll get finally it is what I can, it is 8 is 2 raised to the power 3, and 8 times 8 times 8 is 8 cube, and each 8 can be changed into this 2 cube, and this further I can see that now 2 is multiplied 3 times here, 3 times here, 3 times here. So total number of 2 getting multiplied is 9, or 2, 3 plus 3 plus 3, which is 2 raised to the power 9. So it is 2 raised to the power 9. So 2 raised to the power 9. So I simplified for this. Okay. This and this. Now a power 15 and a power 4 is same as a power 15 plus 4, which is 19, and b3 b4 is same as b3 plus 4, which is 7. I hope this is clear. Okay, you can okay, so let's move on. Okay, so 9, 19 and 7. Okay, so okay, I have didn't do for this. Now the so the remaining term is 4 square, So 4 square, I can write 4 as 2 square, and 4 square is equals to 4 times 4, which is 2 square times 2 square, which is total number of 2 getting multiplied is 2, 2 plus 2, which is 4. So 2 power 4. So I can rewrite as 2 power 4, and here is also 2 power 9, 2 power 4, which can be merged. So 2, 9 plus 4, which is 13. So it is 13. So 2 raised to the power 13, 19 and 7. 2 raised to the power 13, 19 and 7. Okay, I hope this is clear. Okay, so this is okay. So this is not okay. So we lived till here. We are not going to solve it further. So the final answer would be here. Okay. So this is not correct, I think. Now let's move. So the question is root 24 divided by cube root of 200. So in a similar manner, this is like this we have to do. So if you remember the nth root of a divided by nth root of b, I can rewrite as a upon b nth root, but only when these values are same, when these values are same. So to be same uh, to the having same orders, what we do, we'll just use the LCM method. So here from here it is 2, here it is 3, taking LCM is 6. So we make root values of order 6. So 2 multiply with 3, same is 24 raised to the power 3, and 3 multiply with 2, 200 raised to the power 2. Okay, now one can easily solve. I am leaving for it so that you can try. Okay, I hope you can now easily do using this property. Okay, let's move. Now, comparison of surds. So comparison of surds. Okay, now comparison of surds. We know how to compare to natural numbers, whole numbers, integers. Okay, in natural number we know 1 is less than 2 is less than 3. Also in whole numbers there is only one additional number, which is 0. We know 0 is less than 1, less than 2, less than 3. In integers there this follows, but there are negative numbers, but we know also that more the negative, lesser it becomes. So minus 1 is greater than minus 2 is greater than minus 3, and we know the negative values are less than 0 and less than 1, then it follows. Okay, so this comparison we know. Now we are comparing two surds. So how we'll compare? Let's see. If we are given that two surds are given and both are positive, this means x and y are two surds and both are, sorry, x and y are just numbers and both are positive, and n is some greater than 1 is also a positive integer, then this happens. Okay, uh, let's understand through an example, not just by this statement. Okay, let's see. So if you see here that it is given the cube root of 16 is greater than cube root of 12. So let's see, here 16 is given, here 12 is given. Okay, clear. We know 16 is greater. Yes, it is greater than 12. Okay, and both are greater than 0. Yes, yes, it is. So applying, so the if I apply 2 here and root of 2 here, it is true. Okay, okay. What about 3? If 3 was here and 3 was here, yes, also true. So if I apply any number natural number, any natural number, and the same natural number here, same. Must remember the order is same. Okay. Then only we say it is true. Okay. So it is true. Okay. Similarly here, 35 and 25, 35 is greater than. So applying 5 here, it is true. Okay. So quite simple comparing two surds. Let's move. Now we'll see which is greater. So here we won't be comparing easily because the orders are not equal. So what we will do to make order equal? Quite easy, to make taking LCM, and taking LCM of 3 and 5 here. 3 and 5 LCM. LCM of 3 and 5 is 15. So cube root of 16 is equals to 3 times 5. 16, and fifth root of 8 is equals to 5 times 3, 8, 3, which is here is 5. Okay. Now if you see that it becomes 15, 16, 5, and 15, 8 cube. And now whichever among between them is greater, so we can write the inequality. So if you see 16 raised to the power 5, okay, it is quite like 16, okay, 16 into 16, 16 times 16 times 16 times 16 times 16. I know this, it is 256. Okay, 256, and let me do for 8 cube. 8 cube, 8 cube is 8 cube is 512. Now if I multiply this, 16 times 2, 5, 6 is 4096, something like that, 4096. And I can easily say that from this and this, that 16 raised to the power 4 is greater than 8 cube. So I can say that 3 cube root of 16 is greater than 5th root of 8. Okay. In a similar way, I can use for this. So taking LCM for these and making order equal to the LCM and then compare. This is for your home work. Okay. So this is for your homework. So let's now it is it was the last exercise for this session. So thank you for this lecture, the interesting topic of surds. Okay, now for the next time we'll continue on the next topic of the number system, which helps you gain your more knowledge on other topics. Okay. Thank you.